Hello and welcome. This is Michael Hindle. I am a certified Passive House consultant, the owner of Passive House, and president of the DC chapter of the Passive House Alliance. We are pleased to welcome Katrin Klingenberg to be here with us. She's the founder and executive director of FIAS. Um, we thank her for coming here to discuss with us her current thinking on evolving and optimizing the Passive House standard to reflect our diverse North American climate conditions. This is an excellent opportunity for us to hear from her and to ask questions. Please feel free to type in your questions as they occur to you, and we will get to them as we are able. This is a great example, in my mind, of the role of the Passive House Alliance in providing information and a forum for discussion of important Passive House related issues. So please sign up and become a member if you haven't already. And also, I wanted to remind everyone listening to join us for our next Passive House Alliance DC chapter webinar, which is on June 9th at 11 a.m. It's Saturday. And Ken Levinson from 475 will be here to present to us on products that they carry, such as air sealing products, tapes, smart membranes, vapor diffusion, open wall assemblies, and through wall ERVs and the like. So please join us for that. You can sign up at the FAUS website. Before we get started, I also want to thank Mark Miller, the Executive Director of the Passive House Alliance US, for having helped organize this event and make sure it would go off smoothly. And we are also grateful to Roland Talalas and Aramis Sabilis of Intus Windows for hosting our meeting today. Intus is the newest sponsor of the Passive House Alliance and have been active in our local chapter since its inception. And they've done a great job of bringing high-performance windows to the American market at very good prices. So we want to give them a moment to present to our Alliance members who they are and what they do. So I will turn in a moment to Aramis Sabilis. Okay, Aramis, take it away.
Thank you, Michael. It's our pleasure to host Katrin here today, and Michael as well. I'm just going to go briefly our product lines that we currently offer for passive house projects here in the U.S. And so to start with, I will start with our E40 window line, which is a UPVC window, which is a great seller in most of the U.S. Passive house buildings. This is a very affordable option for a lot of the uh, multifamily buildings, schools, or municipal buildings as well. And you can learn more about our product lines on the website, but let me take you through some of the uh, lines again. And you can see the adaptivity for our UPVC windows that can go in commercial and residential buildings, schools, office buildings, municipal buildings, and hospitals as well. In aluminum product line uh, selection, we have Passive House Institute certified windows that are fully thermally broken, triple pane. Also, we have aluminum doors. You can see a different options that we offer: lift and slide, sliding doors, and so forth, as well as aluminum curtain wall system. So idea about the aluminum is that all of our extrusions are fully thermally broken, and we use triple pane glazing within them. Also, we have Passive House Institute certified wood windows with aluminum clad and a thermal break in between. You can see a few numbers for the frames and triple glazing as well. Also, we have different wood options as well, whether using a aluminum clad or just impregnated exterior. And you can see some of the lines here. So please go to our website at intuswindows.com. I would be more than happy to answer you any questions if you don't find an answer on the website. Thank you.
Okay, thank you, Aramis. We are, bear with me for a moment while I switch over to Katrin's presentation, and we will have her in just a moment. Okay, so without further ado, I'm pleased to introduce Katrin Klingenberg and her presentation on climate-specific passive house building standards for the context of the North American climate zones. Okay, Katrin, take it away.
Okay, very cool. Um, just let's quickly do a sound check. Can you guys hear me all right? Well, I guess there's no feedback, right?
You can type in and it's
It's
a
okay.
message.
It should be okay. So if people have a problem hearing me, just type in a message and say it's really bad, speak louder or something to that effect. So first of all, thank you a ton, Michael, for putting this on fairly short notice, and of course also Mark Miller, who had the foresight to call for this webinar in an effort to keep everybody abreast of where the thought is standing right now on the Pascal-specific standards for the United States. The reason that we're here in Washington, D.C. today is actually kind of like a coincidence. The discussion about climate-specific passive house building standards has caught the interest of the National Institute of Standards for Standards and Technology, and that's why I'm here in town. I was presenting to them yesterday, and that's really great news because this topic is finally reaching those making decisions, who are discussing codes and standards and so on and so forth. Let's get started on the discussion of the thought process that was behind investigating or reinvestigating the European current standards and practices and certification criteria that we are designing to at the moment. Our thesis that we like to present at this point, after having reviewed and checked for accuracy and for ease of design and so on and so forth, uh, probably over 100 projects now, well, far over 100 projects in the certification process, some patterns started to emerge. And I like to introduce the thesis from those patterns that we've seen. It does appear that we could use a refinement or tuning of the one-size-fits-all 15 kilowatt hours or 4.75 standard for the passive house for the extreme climates, which means like the very, very cold climates, as well as the very hot climates, such as where we built this first prototype in Louisiana. Um, so initial studies have shown that there is some significant saving potential for site energy usage, as well, of course, as primary energy by proposing such a refinement. And if we're proposing this, you shouldn't think of like, oh, all of a sudden it's going up to like 25 or 30 in Fairbanks, Alaska. We're talking about a fairly small amount, like let's say 18 kilowatt hours or 20 kilowatt hours for very, very cold climates. But then at the same time, we're of course also proposing that in very mild climates, like for example California, we should increase the standard, and maybe it is feasible down there and cost effective to go to 8 kilowatt hours per square meter in a year, something like that. And then on an average basis for the entire country, we believe that that will lead to an overall tightening of the standard, actually. And that is, of course, very exciting if we look at this in the context of the CO2 emissions of, like, which is one of the criteria to arrive at the standard. Um, very quickly, the goals of this whole exercise and investigation, eventually, if we get we are confident to say like, yes, we would like to come forward with a proposal like this. The goal is to come up with a climate-specific passive house standard base, ideally down the road also for net zero energy or plus energy homes, of course, to tie into other programs such as the Challenge Home of the DOE, for example. The goal is to come up with modeling tools of the next generation, which also means that we're looking into newer software options. Certification, we think, is a very important tool to make sure that we build these very energy efficient structures correctly in the various climate zones. Again, very US specific topic. You'll see this later in a worldwide map that I'm going to show you in regards to challenges for passive house and space conditioning needs. So QA/QC for certification programs is absolutely totally critical. And then also we're looking at potentially suggesting some post monitoring collection, of course, for data, but also potentially some post tuning after like 1, 5, or 10 years to check that all the installation is still in place, that all the systems are still performing as well as we had designed them. For that, we're suggesting a development process led by the FIES Technical Committee. There will be various milestones defined. We're looking at starting this process mid of July, and the tech committee will then solicit CPHCs and manufacturers and others who are interested in joining work groups to help define what this proposal should be. And then the work groups will present back to the tech committee, and the tech committee will then make the final decision and then put out the proposal in 3 steps to the community, and anybody can make a comment, and the comment will be considered. So that's the plan, and the first milestone hopefully will be completed for the annual conference in Denver, so that the annual in-person meeting of the tech committee can then decide to put out, hopefully without further revision, for public comment. So you should be seeing something for the first time coming out right after the conference, hopefully, if everything goes well. Okay, so quickly, and I'm trying to get through this really fast so that we have time for questions and dialogue. And so very quickly, some basic design criteria for passive house here, where we think that there is room for improvement in what is currently being considered the passive house standard. Quickly reviewing the metrics that we're using currently and reminding ourselves where they are coming from. And then I like to go through very quickly through some lessons learned through the certification process over the last couple of years, and what might be a suggestion for improvement from those lessons. Okay, so the very basic theoretical framework of the passive house, and we think that it gets lost sometimes, is really the peak load criteria. We are also focused on the annual heating demand, but really the annual heating demand came later. So the peak load was first, and then the annual heating demand was what followed, meeting the peak load of 10 watts per square meter in the Central European climate. So here in this slide, of course, you know all the argument right here. This is a typical building, not very well insulated. The surface temperatures are not anywhere close to be equalized. We have radiant losses to the windows, so on and so forth. You're familiar with this. And of course, our goal in a passive house, we are trying to basically balance out the internal heat gains with the losses in that particular climate. And from there, follows insulation levels that are specific to the particular climate. And a couple years ago, we came across for the first time a provision in the International Energy Conservation Code that made us, be a little bit astonished, actually. There was a provision in there that said if you're meeting the peak load of 1 watt per square meter, you don't have to comply with the requirements that you are meeting the International Energy Conservation Code. Of course, the inspectors immediately threw it out and said, like, well, I have no idea why this is in there, and you still have to do it, because nobody really could remember where this provision came from. We started doing some research, and we found out something very astonishing, and that was that this provision actually has been in there since 1995. It was in the very first international, well, at that time it was the Model Energy Code, as an answer to the oil embargo. Since then, this provision is in there, and that was really amazing. So at that point, they already understood that if you can build a shell that retards the energy loss so much that you can actually almost heat your house by internal heat gains, and that of course means either light bulb, people, appliances, or solar. At that point, you almost have a balanced home, and you have only very little energy that you need to input to keep that building comfortable. And essentially, that's the reasoning why it's still in the International Energy Conservation Code. If you can heat a 100 square foot room with a 100-watt light bulb, they conclude very simply you don't need a furnace or a heating system. And that's essentially the passive house concept. Yeah, okay. I'm trying to talk a little louder. Thanks. Yeah, okay. All right, I hope this is going to, this is a little better now. Okay. So the same principle, of course, in the United States, we have to concern ourselves with cooling very quickly. And at that point, we have to transfer that same principle of the equal in, equal out to the cooling case, which here again in a conventional code home, you can see that the surface temperatures are higher, the glazing is radiating heat, and it doesn't take as much R, of course, because we don't have as high of a delta T as in a very cold climate. So in a cooling climate, we're expecting that the insulation is much less of a silver bullet, and that there will be very different design criteria that actually help us to keep the energy down. But essentially here it is the same idea. We're maintaining an interior set point, we're maintaining interior relative humidity. So again, back to this idea, equal in, equal out, we have a stable interior, and through the retardation measures of the envelope, we're maintaining this climate on the inside. Okay, so from there, very quickly to the current metrics and how this peak load criteria actually plays out in those metrics right now. Quickly, just thinking back to why those metrics came about, back to the 1992 Rio de Janeiro Earth Summit, the factor 10 reduction request by the scientists back then, global warming, CO2 emissions, you're all familiar with that. This slide right here is still stuck at 0.6. The current temperature is roughly 1 degree Celsius in rise of temperature of the planet. So we really need to get to work and stop those CO2 emissions to have a chance to stabilize this increase of temperature. And some real passive pioneers like Douglas Balcom right here, he was one of the very first scientists that was starting to work on energy conservation after the oil embargo. And he was working at the time at Los Alamos. He was one of the very first ones who tried to come up with something similar that Passive House is doing now. It's some kind of like a design concept to try to manage the complexities of passive, of energy conservation, solar, and a very small auxiliary heating system. He draws a very different map right here than the International Energy Agency still in 2006 proposed, that most of our energy will come from coal and oil and gas and so on and so forth. He very early on already said that most of our energy increase needs to be covered by efficiency and by renewables. And here you go. This is really the ideal of our energy society or economy, how it should develop. Okay. Ah, okay. Sounds good. Where was I?
It doesn't matter, just click on that field, it'll come back.
All right, so quickly back to, you all know these slides, the factor 10 reduction. Yes, of course, we are totally behind this. That is where we need to be in our energy conservation efforts. So we're not questioning that at all. So that's definitely a really good target where on average we should arrive at. And that target is entirely possible in climate zones that are very similar to the European heating-dominated climate. So here's the FIES Plus certified Black Beaulieu home in Salem, Oregon, and I'm showing you this right here because for this one we have pretty good monitoring data. And here in this slide, you can see that even in a little bit milder climate of Oregon, we are achieving, compared to a code home from 2008, still about a 66% reduction. And the match of PHPP with that actual consumption was pretty good, except one thing you might notice right here, that the heating is almost non-existent. And that was already a little bit of a question mark that was raised. That is not how PHPP calculated it. PHPP still calculated a pretty large heating demand on an annual basis. So what happened here? Well, it turns out what we see in pretty much all passive houses nationwide where we get monitored data from these days, the internal heat gains, people's Xboxes and servers, they are pretty much one-to-one replacements of the kilowatt hours that we otherwise would need for heating. And that might lead to a conclusion that in a culture where we have a lot of internal heat gains, maybe we are over insulating our houses by going to these levels. Because in this case, in Salem, Oregon, this also had an unintended consequence. In a climate where there should be no cooling load, all of a sudden they caused cooling load in the summer, which of course also increased the energy consumption. So the projected energy consumption in PHPP was actually a little lower than it turned out in the end. And you all remember that slide, of course. This is just the total confirmation that in general, the target with the factor 10 reduction is absolutely right on. If we can get there on average and now transfer that to the United States, allow those in the north maybe a little bit more and tighten it a little bit more in the south, if we still arrive at an energy reduction of roughly a factor 10 or hopefully even a little bit more, then we have achieved our objective from a climate perspective. Okay, quickly, these are our current certification criteria that we're going by. You all know those. You have probably seen the suggestion from Mark Rosenbaum, and I absolutely and totally agree with him that the annual total primary energy demand, we definitely will have to zoom in our studies on that one a little bit more, because currently the certification is based on the European primary energy factor, which in the newer version even got lowered. So we are roughly at 3.3 as a factor in the United States on average. And right now, projects that are being certified using the new PHPP are using 2.6. So that's a little bit, I guess, not very honest with ourselves. And the FIES Tech Committee has started the discussion, like, shouldn't we certify based on the actual primary conversion factor that is the average in the United States? Okay, so one little tweak right here, this slide actually, you've probably seen this before too, if you've gone through the training, it points to another problem, and that is that currently the certification is based on a treated floor area that does not really match with any of the other modeling tools in the United States or other rating systems, for example, the treated floor area that ResNet is going by. And that causes a lot of confusion. People don't really understand that difference. And the treated floor area as used in PHPP is based on German tax law. It really has nothing to do with thermal transfer. So if one really wanted to customize for North America, for the systems in North America, one might have to think about, shouldn't we use like a typically used treated floor area, conditioned floor area, to avoid this confusion. This is, by the way, something similar that Minergie is doing in Switzerland. That's what they did. They adopted the treated floor area or conditioned floor area that was typically used in their customary modeling tools. Another, you remember this slide right here. Again, this is just to make the case that conservation really is the cheapest way to abate CO2, and that is really our main goal with a standard that we hope to tighten on average by being more granular in our definition for the various climate zones. You remember this slide, I'm sure, and I like to point out in this one that this indeed is very specific to Germany. There was something very interesting happening at this international conference in Hanover when I was there, and that was Dr. Feist presenting the same curve, pretty much adapted for different climates. And yes, you guessed right. In his curve, even Mexico City showed a drop at 15 in terms of the savings that come from the heating system, which really is very unlikely in a country that is already using the delivery of space conditioning through the supply air. So there are a lot of kind of like boundary conditions for different climates that need to get reevaluated and really scientifically underpinned. We need to make sure that we have the right data and show that this kind of like philosophy of passive house combining conservation with the most cost-effective way to do so is actually true in the particular climate zone with the particular um, kind of factors that we can use to lower our overall energy consumption. And you remember this one. In other climates, this curve might not look like this. So this is part of this whole idea that we might want to look at like different models for this cost effectiveness that other organizations are actually working on. And we need to give this some thought and see what is up with those. Okay, quickly. Some climate-specific implication. This is really where it gets interesting. You remember all these. I'm going to flip through those very quickly. This is really just to remind ourselves that by now, as a community, we really have made great strides, and we have seen passive houses built in all different climate zones. And I'm not showing each climate zone right here because there are just way too many. But we have arrived at a point where we have these examples and we can study them, like for example this Californian retrofit project right here. And this is really it is a U-shaped passive house. And we were joking in the early days, well, that's cool, that's only possible in California. But the more you think about it, why is there not more traction in California for passive house? This is the leading state in the nation in terms of energy efficiency. Well, the answer is easy. Those who are practicing there tell us, well, people don't see big of a difference because, like, all you got to do is build a little better and tighten your building, and that's it. And so there's no real perceived value there. Like, so it might make sense actually to tighten the standard in California and make people work a little harder so that they perceive it as valuable or as the next step. Louisiana, that one was a very difficult project. We learned the lessons of dehumidification, and we have a pretty good idea how much that actually impacts our load distribution now. This is a huge issue we will have to deal with, and I'm going to show you a map here in a second, which hopefully will astonish you as much as it did me when I first saw it. Kansas City, mixed climates in the middle of the country, also very humid, heating and cooling almost equal distribution. So we have very difficult situation here. We have North Carolina, where the builder here is choosing a concrete prefabricated panel. We have issues to deal with, like hurricanes, where we have to build passive houses that withstand certain disasters. So all kinds of these things have been tackled, and I think we have all successfully shown that it is possible and that we can do this. Duplexes now. Rob Hawthorne in Portland is already onto his second duplex. This was the one he just finished and that is being currently monitored. All fantastic projects, and of course with the duplexes we have already launched into multifamily. There are various large multifamily projects in the design phase right now. This is the very first one that came into our office in, like, I believe it was like in 2007. They still haven't been able to break ground. This is the distillery project in Boston because they ran into some code and issues there. But I think they're getting there, and they will be ready to do so soon. There are a lot of other really great multifamily projects in the works. Tim McDonald in Philly. The housing network is working on 7 multifamily projects in 7 different climate zones. These are affordable projects. So there's a lot of exciting stuff that is probably going to go in the ground like by the end of the summer. So we're going to see all this happening. Of course, Adam Cohen is pushing the discussion forward on the commercial projects. This is the seed project here that he first finished. And this one actually beat the predictions by 6% for the first year in operation. And now he's currently working on a dentist office, as well as his first dormitory in the United States is currently under construction. It's coming out of the modular factory. It's a 100-unit dormitory project in Virginia. So all kinds of really, really exciting things that we're seeing, and here like the seat mechanical room, all that is transferable. Of course, we still need more products and components, of course. Yes. Back to the climate specific standard discussion. So we used to say like, well, the European climate is similar to around the edge of zone 5 and zone 4. But of course, that is not entirely true, because the right two-thirds of the United States are very humid, and that causes a very different condition. And also zone 7 and 6, and even the top half of 5 are very, very cold. So also Central Europe is not necessarily there. Of course, like the Scandinavian countries are getting much closer to that level. So it turns out that there's a global buildings performance network, a fairly young organization that has recently taken on uh, the look of passive house worldwide, and they have commissioned a very exciting report that I was able to review before they launched it actually this last week in Paris. And they did a study worldwide for China, Europe, for the United States, um, and they were trying to prove that prove the potential of passive house standards worldwide as effective of the CO2 abatement, and that we actually really need to do it, and that we internationally need to go there as a and they are currently working on some kind like of a democratic worldwide passive house strategy. Um, they went in and did what I thought for a long time somebody should have been doing, and I wish we had had the time. These maps are absolutely outrageously exciting to me, because finally somebody went in and looked at the climate specific factors for space conditioning. And here in the left upper corner, we're seeing the heating degree days, the cooling degree days on the right. Then on the left, on the bottom, the relative humidity, and then the average air temperature on the right. And then, of course, you will be asking that question yourself. What happens if we overlay all those? This happens. And this is the actual map that made me really excited when I first saw it. So finally, we have still could be more granular, of course, but finally we have a really good idea how drastically different the space conditioning needs in the United States really are. And if you look at this map, it looks more like China than anything else. And the gray is in Central Europe right there, is just a little tiny stretch on the bottom between 4 and 5. Um, and everything else is either colder, warmer, cooling, and dehumidification. So we have a huge challenge here, because the combination, of course, between cooling, heating, and dehumidification is not only important for the mechanical optimization of the system, but also it requires different rules and solutions for optimizing these different loads against each other. And if we're using heating as our main criteria, or cooling as our main criteria, or dehumidification as our main criteria, we might inadvertently make the other one worse. So we need to come up with a strategy that allows us to optimize all those space conditioning needs with each other to achieve the most optimal solution. So I think this map is going to be a really great beginning for us to be able to start analyzing which systems are the best for what particular climate zone. So I'm very excited about having this. And then that leads me to the next slide right here, which is has been created by Ty Newell from Ty Newell Instruments. He's, by the way, about ready to launch his CERV, which is he introduced to the Passive House community in Duluth during the second Passive House conference. They are finishing up the UL listing. I'm going to retrofit my house with this new mechanical ventilation system, which does heating, cooling, ventilation, um, all heat pump based. So I really want to see uh, from my perspective how this is going to work, and I'll report on how this is actually working for the Passive House shell. So, but generally, this shows right here our passive house peak load principles. We're saying like we're not going to use more for cooling than like 2,000 watts to the right, and for heating between 0 and 3,000 watts, and then we have a certain load that we need to spend on latent, and the goal is to end up in the comfort zones for temperature, of course, the 66 to 76, and the 30 to 60% RH, and those zones are pretty narrow. So this is a challenge, and that goes back to what are our design strategies for the envelope to allow our mechanical system to operate within this operational range. Just quickly, again, highlighting the additional dehumidification loads and difficulties in the United States. Here, basically the right half uh, does have dehumidification needs. Some of it in the furthest north probably can be taken care of by cooling, so it's not that big of a deal. But definitely in the lower half of the right-hand side, we will have to do some additional dehumidification. And just another slide right here said thing, high dehumidification loads. You know all these slides, the consequences for the different climate zones. We have different R values, different requirements for our windows. Um, and same thing is true for our ventilation systems. We have ranges for the ventilation system here as well that we need to zoom in on. And that whole ventilation system thing, I just recently learned that the new certification criteria from the PHI are making people subtract 18% for non-certified units. Um, that is really starting to be completely unworkable, and we will have to really investigate what the truth is and how those North American units are actually coming in terms of performance. And FIAS will tackle that as well, the tech committee, parallel to the whole standards discussion. So proposed US standard modification. Now, I was saying earlier that this Central European cost optimized curve is very specific to Central Europe because they typically used to heat with hydronic heating, and that's a very expensive system. In countries where people are using already supply air to condition their homes, that drop is not anywhere close as dramatic. So BOPT here from the National Laboratory, from NREL, it's a different approach. So here we can see that this dramatic dip does not occur. That it is more like a flat curve with a little bit kind of like an optimum in the middle. But then really it doesn't matter if you go a little bit right or a little bit left. You have a range, you have a spectrum to choose from where your cost effectiveness is okay. And as we all know, cost fluctuates. So the designer will be able to choose right or left of this optimum and be still fine from a cost perspective. Now, this is a slide from a fantastic master's thesis right here. Bruce Kruger undertook the first investigation in regards to climate-specific pH standards, and he found some interesting things. He ran all projects through PHPP, one project through PHPP, through Energy Plus, through BOPT, and he did that for 20 cities. And then he compared the results. So the interesting thing that he found was that this cost optimization curve for cold climates is very kind of like rather flat. You have a lot of option right or left of it, and you can choose your level of final energy savings. In a climate like Phoenix, very extreme cooling climate, that cost optimum is different. The curve goes up very quickly. At a certain point, there's really no point in investing in efficiency. The cost just skyrockets there. So there are some different characteristics that that we see in different climates, and that will definitely be taken into consideration when investigating what level of energy savings should be achieved in what climate. So Bruce came to a very interesting conclusion. He said, well, we really need to optimize heating and cooling demand against each other. We can't just look at one or the other independently. And I would say here, I would like to see another column for dehumidification as well. And then from there, from his optimization, then he concluded a total space conditioning demand as a certification criteria. And that's one approach that I'm not saying that that's what it's going to be, but that seemed to make a lot of sense when I was first introduced to the idea. So that is one possibility to think about it. And you can see the various cities right here. It's really interesting because let me see if I can go back here for a second. I don't have Chicago. In Chicago, something interesting happened. We always thought that Chicago was already kind of, oh yeah, there's Chicago. Okay, super. So that Chicago was already fairly difficult to get and to meet the standard. But turns out if you take the approach of optimizing both space conditioning needs together, Bruce came to the conclusion that actually the Chicago values could be tightened against all expectations. So this is all really interesting stuff and deserves a closer look of the tech committee to see what exactly happened here and if this is a take that we can follow. Yeah. So that's essentially our plan. I'm not saying one way or the other right at the moment. The tech committee will take on this challenge and will recruit volunteers to discuss this and to bring people into the discussion, and then through the public comment period, hopefully come up with a proposal that we can agree upon. And then once we do that and we can agree on some climate specific standards, obviously we'll roll this into the FIAS Plus certification. We very strongly believe that QA/QC in the United States, especially with the added challenges of hygrothermal performance of the wall assembly in the very humid areas, is very, very critical. We will fold it in. We are not really sure yet if this is going to be in terms of like versions of standards, because we expect the standard to develop. We are just at the beginning. Technologies are developing, new technologies, and they all will have kind of like an impact back on what we think or might think right now what the most efficient way is to design these structures. But certainly new technologies might shed a totally different light in like only a few years. And of course, we will continue to train consultants to be able to guide that design process safely for the people who are embarking on passive house to assure um, the most quality assured projects that hopefully then also perform for many, many years to come as we had designed and envisioned them. And in all that, of course, you guys, the Passive House Alliance, the members, the professionals on the ground, this is your alliance. You get involved in discussing the standards and inform the process, and we will do our best to re-inform back on what we find in the technical committee. And hopefully together we can move all this forward. And again, in Denver, that's our target for the timeline, to put out something after that conference, after the in-person meeting of the technical committee. And there was discussion of making that discussion of the technical committee open for other people to sit in, of course. So hopefully after the conference, we can issue the first proposal for public comment. So that's it. That's what I have. If you guys have questions, concerns, please ask away.
Okay, thank you, Katrin. That was very informative and exciting. We don't have any questions showing up at the moment, so we'll give you a few minutes, but please do fire away, and we will try to take them in order and as time effectively as possible. Does anyone here have a question? I have one, actually. I could throw it out there. We're talking, this is Michael Hindle again. Katrin, we're talking about climate-specific design standards, and it occurred to me that a national average primary energy factor could be something that does not accurately reflect the primary energy factor for a given region. There could be a wide range of difference between Portland and, say, here, where we have a predominance of coal-fired plants. So I wonder if an additional layer of granularity would be that we could have localized primary energy factors, which I believe the Department of Energy maybe already has available for us.
Well, they probably do, but that might price some people completely out of the passive house range because you're completely coal-fired, and some people in Oregon might just have to build a tent or something. Yeah. So back to that slide of from the CFUS project, our goal needs to be to get our total CO2 emissions down on average as a country. And if we can find a good way to assure that, so I'm not sure that localized primary energy factors will actually lead to that goal.
Okay, great, thank you. We're starting to get some questions in, so I'm going to just take a moment to make them visible for Katrin, and then we can just take them one by one.
Uh-huh. Cut off there. What is OMG?
Oh my God.
Oh,
that came up. There was one comment while we were looking at the maps, which was OMG. Oh my God. So there we go. Now it's visible.
All right, super. So the question is, once the public comment is over, who is the? Oops, there's something missing, I think.
Who will be making the final decision on adopting the new standards?
Oh yeah. So okay. So I didn't talk about this in much detail. The idea is that the various approaches will be split up into work groups. We'll come up with ways how to tackle this and how to investigate the standard questions. Each tech committee member will take basically a chair role and then solicit work group members. So anybody who's interested in volunteering for that, please help, because everybody on the tech committee is already very busy, so we're dependent on people jumping in and participating. And so we're looking at basically a structure very parallel to how codes are developed. The technical committee will review what the work groups find. Then it will go out for public comment, 3 weeks. There will be a transparent process in regards to every comment being heard and being discussed. And then the tech committee will revise the proposal again in work groups, and there will be another public comment period for revision, and they will be worked into the proposal. And then once again, and then the final decision will be an open meeting, at least that's how we're envisioning it right now, by the tech committee, where people can sit in. We don't know yet if directly with feedback or not. We will have to see how we can organize this. Okay, will this presentation be available online? Yes, it will be. Maybe regional, but not too local. Yes, that's right. We're definitely not going in and creating like 16 standards for California, and then I don't know, however many for each other state. It will be not that granular. To participate in the tech committee, should we contact FIAS? Can you post this presentation? Yes, presentation will be posted. Yes, if you want to get involved, please contact FIAS. That's right. That's what you should be doing. Michael, this is kind of relating to what you had asked before. Oregon, oh, oops, this is, I think, just a comment from Skylar. Oregon is 50 to 70% coal-fired. Hey, I thought you guys had a lot of hydro over there. Okay, so anyway, I guess we discussed this. I really think that on average is a better choice. But again, the tech committee will discuss what the options are. What is the status on the relationship with ResNet, DOE, Challenge Home? Excellent questions. Okay, ResNet first. ResNet is very excited. We have moved past the memorandum of understanding stage, and we're rolling out the Fierce Plus radar training right now. The next training is going to happen at the end of this month at VEIC, Vermont Energy Investment Corporation in Vermont. And for the first time, ResNet and Fierce are co-promoting this training. The blog on this training is up on the ResNet website and went out to the entire ResNet community, and people are getting very excited. So we're seeing lots of great interest, and we've also seen already some really successful QA/QC happening on site. So it's working. We're catching some stuff. Um, for transparency.
DOE.
Oh yeah,
maybe?
DOE. Oops. Yes, almost jumped over that one. That's a very exciting one, actually. This is kind of a reason why I'm here this week. Yes, we are starting to collaborate with the Challenge Home as we speak, and it's very exciting. So, FIAS and DOE are now partners and are working together, and you will hear about that partnership more very soon. For transparency, you might want to publish this process uh, and as well as the names of the tech committee members. Yes, absolutely. Uh, the tech committee members, I'm not sure why they are not up on the website yet. It's probably capacity, so I apologize. We're in the process of reworking the website right now. So hopefully this will all be much better organized and much more visible sometime soon. So it's not intentional that people are not published. Yes, we will do our best to make this transparent.
We have a comment that says that the audio is down. Just there's also a comment asking if this is being recorded. It is and will be available on the Faust website. But as far as we know, the audio is working for most. So Dan, you could call in um, or see if you've inadvertently hit your volume on your computer. So moving on to the next question.
Hmm.
Um,
Okay, the next question is: has there been any consideration for handling the fact that smaller homes do worse than larger homes? Yes, this is one of the issues that we're looking at as well. Again, I don't want to jump to any conclusions. In my personal opinion, it's kind of like one of those challenges, very similar to having an existing home where you have dormer bridges you can't really get rid of. So it's kind of like an additional challenge, or you are designing a project where the site is not as well located as it should be. That's an additional challenge. So there will be a process to handle that problem, just like the other additional challenges.
so does that, I think that question leans towards the question of a primary energy per person, which you addressed. So is there, but then you discussed the cost benefit curve relating to uh, uh, the kW per square meter.
Yes.
So is there, maybe this is obviously another thing you wouldn't want to make a statement definitively about right now, but is moving away from the sort of energy use intensity towards energy use per person um, something that's being considered?
Well, again, yeah, I don't know this at this point, and this is what we're leaning on you guys for. Like, if you have ideas how to look at this differently, please fire away. Yeah, we're not afraid at um, looking at various ideas, and maybe we come across a way to look at it this way that we just didn't see before. Yeah.
Right.
So the tech committee will, after this process, will make the final determination on the proposed standard. That's currently the plan, yes, after 3 rounds of public comment. Next question. Players will have a new forum opening up on the members only area of the website for people to continue the dialogue after the webinar. Absolutely. It will be live in a few days, and that is a great forum. So they are all the good ideas will be recorded and definitely will be considered by the tech committee.
Okay, we discussed that.
Um, have any of the studies that you cite on the 100 projects that you looked at been made publicly available? Um, well, they are on our database, at least the ones that have been fully, completely certified. The other ones, a lot of them, well, a lot of them, some of them we look at, and they might not go for full certification. They might not pass the blower door test. So it's really based on like what we've seen through various design stages. Some of them didn't make it to certification, but we are intending to publish conclusions, or at least, well, again, this is going to be part of what the tech committee will have to analyze. And yes, the idea is to publish that at some point.
Okay.
Are any other correlation studies that have been done to correlate REM and pH been made public? Well, that has been made public to the FIES Plus raters. Yes, this is not a secret process. The FIES Plus raters are trained in that process, and I'm sure there will be presentations at the upcoming annual Passive House conference to make that um, process open and known. There's nothing secret there.
This next question looks like something specific to practice. I don't know if you want to answer that.
Okay, so the next question, is it prudent to use a moisture barrier that is variable in high humidity hot climates, especially in hot climate renovations? Well, that's a specific hygrothermal question. I think this goes a little bit beyond of what we're discussing right now. Next question. As the climate-specific standards are rolled out in the US, does FIES plan to differentiate the certification for those buildings from the ones that are still following the original standard? Yes, of course. And we have been discussing to offer both parallel. Uh, yeah, again, this goes back to the process. At this point, it's really hard to say uh, what will happen. I can tell you from my personal perspective. I do think that being more granular based on climate will lead to a significant reduction in energy use. And if I was certifying a project and there is evidence for that scientifically, and that's what we're shooting for here, everything needs to be based on science. If somebody can show me that that's the case, then I would go for that certification. But sure, if somebody wants to use the European standard, why not?
Um, Katrina, it occurs to me that some of the public dialogue around this issue, such as blog entries and published articles, have talked about relaxing the passive house standard. And whenever I read into the articles, I found that that's really not what you were saying at all. And so I think this article, this presentation is very helpful because it clarifies what you just said, is that overall you anticipate that energy use would be reduced rather than increased.
Yes, that's the goal. Absolutely. Okay, next one. Will this be a residential standard? Well, the overall overarching goal is to tackle this as a residential housing standard, as a commercial standard, and both for existing and for new construction. Okay, next one. Has there also been any consideration to allow solar thermal and interior mass to make up for some of the annual heat demand? Well, the interior mass is already figured into the energy balancing. So that's in there, and solar thermal is in there as well. So I guess I'd say the balance is already um, accounting for that. That said, Michael, Santa Fe, yes, um, I do foresee that in your climate, there will be more emphasis on solar than on insulation. Just a sense. And I think you're right on what you're saying right there. There will be more weight on that, yes. If dehumidification will be a certification factor, will PHPP need to be updated to handle that calculation? Not sure how to answer that one. You know what? I spent many years of my life trying to argue for improvement of PHPP. Um, all I can say for that one is I've given up on that one. We're looking at other options, to tell you the truth. Um, more later. Is thermal mass more of an issue in different climate zones? Should PHPP look at that more precisely? Well, I guess that goes back to Michael's Southwest question. Yes, I think we're going to see various factors play a more dominant role as we zoom in and we check on how optimal the use of those various factors is in various climates. Um, will fears also consider air leakage per square foot of surface area versus ACH 50, which is volume dependent and is more lenient for larger buildings? Oh, wow. So that's getting, yes. um, how to answer that one? I think that goes in the direction of the discussion. For example, during the Fierce Plus radar training, we started to discuss, well, in an effort to make RAM rate and PHPP kind of like talk to each other, what about the different boundary conditions that are being used for calculating the volume that the blower door references? Should we adopt the ResNet protocol? And we found that question fairly easy to answer because it makes it essentially harder if we adopt the ResNet protocol. Uh, that the result would be tougher than if we calculated the same volume based on PHPP rules. Now, to switch all the way to leakage per square foot, that might be a bigger jump, but I would not be afraid to pose that proposal. What are the general subject areas of the working groups, and how does one get involved? How will the working groups communicate online, in person, etc.? So that is all stuff that will be organized during the next month and a half. So please sign up, and we are in the process of working out all these logistics, and we will let people know who are interested in getting involved in this. Um, the topics, again, you guys send in how you think we should tackle this. This will be the very first organizational meeting on the topic by the tech committee, and we will discuss uh, the topics that look the most promising and that those work groups should be organized by. All right, next one. Are there considerations in a way to address the typical higher user loads, plug loads, etc.? Awesome question. Inherited, inherited in commercial buildings that make attaining pH much more difficult for that building type. Uh, yes. Now that is not only a question for larger buildings, but also for actually residential buildings, because the internal loads are nationwide much higher and they are skewing the energy balance. So something needs to be done to address this. As I mentioned earlier within the presentation, it does funky things to the internal balance of the passive house because we're assuming less internal loads, so our calculations are less accurate. So we need a better way to assess what is actually present in terms of plug loads, and that is true for residential buildings as well as commercial buildings. But I know you're aiming at like the higher process loads in commercial buildings, and Adam Cohen is actually struggling with this. Well, struggling. I think he's doing pretty well in kind of like assessing this. So there will have to be specific rules that will have to give commercial buildings a little bit more leeway, I think, to not price them out of the market. But this would also be something that needs to be considered from a tech committee perspective, and data needs to be collected and decisions need to be made. So lots of work ahead. Is PHI open to collaborate with FIAs in these changes? Well, PHI is not open to collaborate. They weren't even willing to shake hands. That was actually why I went to Hanover this year, and nope, they closed the door. So we got a very clear answer, not interested. You mentioned there was an updated PHPP version. Well, there was an update that came out for the 2007 version. I don't know. I think it was like about 2 years ago, maybe, or 1 year ago, maybe. And that one, what was the context I mentioned that in?
You mentioned that in the context of changes for humidity, but you had discussed that you were considering other options. So
yes, so the update to the 2007 actually had an updated primary energy factor from 2007 to 2006, because the Europeans are doing really well right now. They have lots of renewables, so their CO2 emissions actually came down, and they were able to reduce their primary energy factor because their system is so much more efficient now. Not here. Um, the 2012 version of the PHPP is about to come out, and there is, I believe, a formula now out there by which you are calculating dehumidification that is allowed within the European standard. But quite frankly, from my perspective, I don't think neither cooling nor that ad hoc addition of like some budget for dehumidification is doing the US any justice. I mean, it's kind of like odd anyway. So it started all with the 10 watts per square meter, and meeting that one in Central Europe. So that then resulted in 15 kilowatt hours per square meter in here. That was a consequence. And then for cooling, which doesn't exist in Europe, we just mirror that 15 kilowatt hours per square meter in here. Doesn't make any sense. So there really hasn't been done any good research. And I think we need to go back to the principle. So what's our peak load principle for cooling? And then kind of define based on climate what the annual consumption should be from there. And that also asks the whole question of definition in Europe right now. A passive house is a building that can be conditioned by using solely the ventilation air that is needed for indoor air quality. So all heating and cooling needs to go into that. That's the definition. We are, I have to be frank, we're challenging that at this point.
Katrin, I think that question might, in some people's minds at least, raise the issue of what is the FIAS accepted or preferred version of the PHPP that we should all assume we're all using, because as updates come out, if the primary energy number is lower, and we wouldn't necessarily want to give ourselves that break, then you maybe have a which version is the appropriate version.
Well, as of right now, we're sticking with what the Europeans say. If you wish to make it harder on yourself voluntarily because you think that's the right thing to do and use 3.3, please go ahead. I feel that's a worthwhile conclusion, probably where it should be. And this is probably going to be one of the questions that the tech committee will tackle first, because we need to be honest with ourselves, right? If we kind of pretend we're using as much as the Europeans use in terms of CO2 emissions, that's not going to help us. So something needs to happen. Okay, next one. Is a safe use type study underway in the US? If so, how do CPHCs contribute to this effort through post-occupancy data of their buildings? There are various approaches, I suppose. So kind of like through certification and through people monitoring their homes, we already got some data back. The FIAS Plus certification committee is also somewhat talking about trying to create an incentive for people to put in monitoring systems into their FIAS Plus certified homes and to send the data back at least for 1 year to FIAS for such studies. We haven't gotten there yet. The idea is at this point to find maybe a monitoring system that is very cost effective that we could wrap as a distributor, and then we would basically forego our or a share that you would normally get as a distributor and pass that on to the person who is going for certification to make it cheaper and to make it more attractive. We're not going to require this, even though, of course, it's very tempting. ResNet is doing this right now. I suppose if you get a Hearst rating, then you're getting entered into that system also. So this is also something we have to discuss because that data is really, really important. The closest to the CFIUS study right now that is planned is this Affordable Housing Network multifamily project. Also, ORNL and Fraunhofer are talking about a larger proof of concept study through the Oak Ridge National Laboratory, but that is highly dependent on funding, and that funding currently is not in sight. So we will have to see what happens. Are there published data on temperature and RH over a 12-month period for some pH that are being monitored? Yes, there are. Turns out that the temperatures, at least the Fairview house has been monitored now over 2 years. Temperature was very close, first floor, second floor, within 3 degrees F. It was actually an excellent result in terms of temperature distribution, very constant, and the RH was always between 40 and 60%, just like the ideal case would draw it up. All right, next one. Will there be a differentiation in the qualification of consultants similar to lead APs? I'm not sure what that question is all about.
Perhaps the writer could rephrase the question, but I wonder if that refers to how LEED has branched off into LEED for homes versus LEED for commercial versus new construction, new development. You know, there are different categories of certification.
Well, we're not planning that as of right now. I think there's still great value, and this is also what we've kind of like been thinking in regards to the curriculum for FIRS. And in fact, we are revising the curriculum right now, even more so, incorporating multifamily experiences and design guidelines and suggestions as much as we're revising the curriculum for commercial projects. And well, we can do that because we're getting all this really great data and details in on projects that actually have been realized. So we want to pass that on to the community. And I think it's really important that whoever takes the training is really skilled in all different areas. And that will only raise the value of the certification if we can maintain that really high quality and knowledge level of the CPHCs. And we're also focusing more and more on the hygrothermal importance because of that knowledge of that like big blob, this big black blob on the map. In regards to dehumidification, it's really important that we do it right and that we don't have failures because that will drag everybody down. From Pacipedia, the energy threshold of 15 kilowatt hours per square meter and year for heating has been defined for typical Central European climates based on calculations as well as practical experience. However, it is supposed to serve a rough benchmark which may vary with different climate conditions. Yes, and Jürgen Schnieder still says that in his papers as well, but Dr. Feist on stage insists that 15 works everywhere. I heard there is a PHPP 2012 version out. Is there any plan to translate and adopt use of this new version? Do you know what the new what the news is in the new version? Yes. So the new 2012 version, and it is supposed to arrive in English pretty soon, or has already arrived. I'm not sure. The word was end of June. End of June, really? Maybe it hasn't arrived yet. So it is out in German, yes. And it's kind of interesting what the changes are. The peak load for heating moved back up into second place on the verification page. There's an annual latent load now on the verification page, which doesn't really help us. I mean, it's a nice move to kind of answer to people asking for this, but annual latent was already in the PHPP, and it doesn't help us to size our mechanical system. We need peak load. We need to be able to calculate peak load. And there are various organizations in the US who have put together calculators to calculate peak load based on ventilation volume. Very exciting. I'm trying to track them down right now, and we're going to make those tools available as soon as we can. The new version also allows you to toggle and to switch to NFIT. So if you're designing for a retrofit standard, it will no longer say no if you pass the 15. Also, by the way, it has been improved for ventilation systems for larger buildings. Okay, next question. Does this mean the heat demand is actually more flexible? Well, not if you ask the PHI. If you ask us, yes, this is what we're embarking upon. We are saying that the heat demand should be more flexible. That's right.
We have one or two questions, and I think we're going to sign off. If anyone has something they absolutely want to get answered, please send it in right away. We're all hungry, I think.
Yeah, I think so too.
But in any case, we have a lot of positive response here already, and we look forward to more dialogue. One or two more quick questions, and we're going to sign off.
Lois, yes, I agree with you. We need to revisit how we treat PV. The reason that it was excluded in the German, and again, this is a very European kind of effect, that it was not included in the energy balance from the original PHPP was that in Germany you weren't allowed to use PV energy on site. You had to put it all into the grid. And at that point, it occurred the losses and so on and so forth, and it had to be calculated in. Here, a lot of people are using their PV. Like, there's even discussion of switching entirely to DC in the house for some uses. People are definitely focused on the zero energy, and we are going to shift to that as well. Our partnership with the DOE and the Challenge Home is aiming at that. We pledged that we together will work on the best conservation basis for net zero energy homes. Updates for 2007 PHPP, call PHI.
Okay, so that is all the questions we have. We had over 100 people attend the webinar, so it was clearly a topic of great interest, and I think it was a terrific presentation. Thank you, Katrin. Thank you again to the newest sponsors of the Passive House Alliance, Intu's Windows, for hosting us today. And please give them a call and check out what they have. I'm in the showroom, and they have some very beautiful things here. So we're all excited to have done this and appreciate everyone's attention and look forward to continuing the dialogue. So, signing off from our nation's capital. This is Michael Hindle of the Passive House Alliance DC chapter. Goodbye, everyone, and thank you.
That was great.